Deep dive. Today, we're tackling a really interesting frontier: how to make large language model searches, well, even smarter,
Mm-hmm.
especially when they need to dig up knowledge that wasn't actually in their original training data. The very latest info, super specific details, maybe even proprietary company stuff.
Exactly. And I think most people listening have probably bumped into these limits, right? You ask an LLM a very precise question
Yeah,
and you get back something kind of general or just a sorry, I don't know that.
right.
So, our focus today is really on a newer, more academic approach that's trying to push the envelope on these LLM search abilities.
Okay, so less about just getting better summaries and more about the how and why behind the improvements, the actual innovation.
Precisely. Understanding the fundamental shifts in how we're thinking about this problem.
And the current sort of dominant method for this is Retrieval-Augmented Generation, RAIGE, right?
Ruggy, yeah. It's basically the idea of giving the LLM a tool to go fetch external information when it needs it, like a research assistant.
Okay, and we've got some sources today that focus on a really novel way to make RAG better.
That's right. The main one is a paper called ReZero, Enhancing LLM Searchability by Trying One More Time.
Hmm,
It's by Alan Dow and Thinla from Enlo Research, and it's very recent, April 15th, 2025.
trying one more time. Okay, that immediately sounds intuitive. So what's the core problem they saw with existing methods?
Well, the authors noticed something interesting. Existing RAG setups, they're good at doing that initial search,
Right.
but they often don't really have a built-in mechanism to explicitly encourage the LLM to, well, try again if that first search doesn't quite hit the mark.
Okay, so if the first search fails, it just kind of stops or doesn't know what to do next.
Pretty much, there isn't that built-in persistence, and that's exactly where ReZero comes in. It's designed to tackle that potential brittleness, that reliance on getting it right the first time.
Okay, let's really dig into this then. The innovation, the core idea, is rewarding a retry. Can you explain the sort of academic novelty there? What makes it different?
Yeah, the real novelty is that ReZero uses a reinforcement learning framework specifically designed to reward the action of trying another search query after the first one fails.
Uh-huh.
This is a big shift because most other work tends to focus on either making that first query better or doing smarter reasoning after you've got the document.
Okay, so it's not about the perfect first shot or analyzing the results better.
Not primarily, no. Think of it like this. Many systems see a failed search as like a dead end. ReZero says, hold on, maybe that first attempt was just a starting point. It's more like how humans explore, right? If something doesn't work, you adjust and try again.
That makes a lot of sense. Very intuitive. So if other researchers are focused on, say, making that first search laser accurate or making better sense of whatever comes back, ReZero's asking, but what if you miss?
Exactly. So, for example, there's a paper, Rearter, that focuses on making the reasoning more trustworthy after you retrieve stuff. Their innovation is about how the LLM processes and synthesizes the info it found.
Right, so readers about smarter use of what's wrong.
Correct. And then you've got other approaches like deep retrieval. Their innovation uses RL to optimize the initial query itself. They want that first search to be as good as possible based on retrieval metrics.
Okay, so reorder equals better reasoning after, deep retrieval equals better initial search. How does ReZero stand out uniquely?
ReZero's unique angle is rewarding the explicit act of trying again. It's less about perfecting the first attempt or the post-retrieval analysis, and more about incentivizing persistence, recognizing that iteration might be necessary.
That's a really clear distinction. A fascinating one, actually. Okay, let's get into the more academic weeds then. How does ReZero actually do this? What's the mechanism?
Right, so it uses reinforcement learning, RL. Specifically, they employ a technique called Group Relative Policy Optimization, or GRPO.
GPO, okay.
Yeah, and the academic plus here is that GPO has shown it can train LLMs for reasoning tasks pretty effectively without needing a separate critic model to judge the actions. It makes the training a bit more streamlined.
Interesting. So a specific efficient RL technique. How does ReZero use GRPO to actually enable this retry loop?
Okay, so within this RL setup, the LLM goes through this kind of interaction loop. It generates a search query. They represent it as search in the paper.
Okay.
It gets back the information. And then, crucially, it can choose to generate another search query, potentially multiple times, iteratively refining its search before it finally gives the answer.
Ah, so the structure allows for that back and forth with the search tool.
Exactly. And the absolute key innovation here is a specific reward function they introduced called reward retrieval.
Reward retrieval. And how does that function actually work? What does it reward?
It's pretty clever, actually. It gives a positive reward signal to the SLM for every subsequent search query it generates after the very first one in that conversation turn.
So just for trying again, it gets a little nudge.
Yeah, a direct incentive not to give up if the first try wasn't good enough.
Okay, that makes sense for encouraging persistence. But how do they stop it from just searching for it ever? Like endlessly retrying and racking up costs or latency?
That's a really critical point, and they address it elegantly. The reward retrieval is conditional.
Conditional on what?
Conditional on the LLM eventually producing a correct final answer, the answer tag containing the right information. So if it retries 5 times but still gets the answer wrong, those retry rewards essentially don't count towards its long-term learning. It only gets the benefit of the retry reward if the persistence pays off.
I see. So it encourages trying again, but only if it leads to success eventually. Productive persistence, that's smart.
Exactly. It balances persistence with accuracy.
Okay, so that reward retrieval is the core innovation. Are there other rewards shaping its behavior too?
Oh, yeah, definitely. It's part of a larger suite of rewards to guide the learning properly. There's reward correctness, obviously how accurate is the final answer. They mentioned potentially using an LLM as a judge for this.
Right, got to get the answer right in the end.
Absolutely. Then there's reward format. Basically, did it follow the conversational rules, use the tags correctly? Rewardum chunk gives points if a retrieved piece of info exactly matches the known ground truth. Reward search strategy looks at the overall quality of the search process.
Okay.
And reward search diversity, this one encourages trying different kinds of searches or using different operators rather than just repeating the same failed query over and over.
So it pushes the model to actually try different things if the first attempt fails, not just the same thing again.
Precisely. It encourages smarter exploration during the retry process.
This sounds like a really well thought out, multifaceted reward system, designed to get it to retry intelligently.
That seems to be the goal. And there's one more technique they use during training that's quite interesting from an academic perspective. Noise injection?
Noise injection. Wait, they intentionally made the search results worse during training? Why?
It sounds counterintuitive, right? But think of it like making the training harder to make the model stronger. By adding a little bit of noise or imperfection to the retrieved information,
Yeah.
they force the LLM to become less brittle, less reliant on getting perfect information back on the first try. It has to learn to cope with slightly imperfect results and use that retry mechanism more effectively. It simulates the messiness of real-world retrieval.
Okay, that makes sense. Training wheels off, but in a controlled way, a sophisticated way to build robustness. So they have this novel framework, this reward retrieval. How did they actually test if it worked? What was the experiment?
Right, the validation, they did a pretty standard controlled experiment. The base model was Llama 3.2-3B instruct.
Okay, a known model. And the data?
They used a specific data set focused on the Apollo 3 mission. It had about 341 chunks of text, and they set aside 32 of those for evaluation, so a defined knowledge domain.
Apollo 3. Interesting choice. How did they do the training and comparison?
They trained for 1,000 steps on one NVIDIA H200 GPU. The key thing was the comparison. They trained a baseline llama model without the special reward retrieval function.
Right.
And compared it directly against the ReZero model, which did have reward retrieval. Everything else was kept the same to isolate the effect of their main idea.
A clean A/B test. Perfect. So what did they find? What were the numbers?
The results were, well, pretty compelling. The ReZero model, the one with the reward for retrying, hit a peak accuracy of 46.88% on that evaluation set.
Okay, 46.88%. And the baseline?
The baseline model without the retry reward only peaked at 25.00%.
Wow, okay, that's nearly double the peak accuracy.
Exactly. And interestingly, the ReZero model also reached its peak accuracy faster, around 250 training steps compared to 350 for the baseline.
So it learned faster and reached a significantly higher peak. That really seems to validate the reward retrieval idea.
That's certainly how the authors interpret it. They argue this gap clearly shows the benefit of explicitly encouraging the model to try again when needed.
Now, in good academic fashion, did they also talk about any limitations, any catches?
Yes, absolutely. And that's important for a balanced view. A key limitation they noted was that both models, ReZero and the baseline, actually saw their accuracy decline after hitting that peak, eventually went down towards zero.
Huh. Why would that happen?
They suggest it might be due to instability in the RL training process itself, which can sometimes happen, or perhaps overfitting to the training data. They reference some other work on challenges with RL generalization.
Okay, so getting those initial gains was impressive, but sustaining that peak performance was tricky.
Right. It suggests more work is needed on stabilizing the training over longer periods.
Any other limitations?
The other main one they acknowledged was the data fit. Using only the Apollo 3 mission data means you have to be cautious about generalizing. Would it work as well as, say, medical data or legal texts or just general web search? That's still an open question.
That makes sense. You need to test it in more diverse environments. So, based on this work, what do the authors see as the next steps? Where does the research go from here?
They lay out a few clear paths. Firstly, exactly what you just said, evaluate ReZero on more varied data sets and different kinds of tasks to really test how generalizable it is.
Logical next step.
Second, investigate ways to stabilize that RL training, address that drop-off in accuracy after the peak, maybe different RL algorithms, maybe different training schedules, who knows?
Right, tackle the stability issue. And I guess dive deeper into the reward itself.
Definitely. They want to explore variations of reward tree, like should the reward get smaller with each subsequent retry, diminishing returns, or maybe only give the reward if the new search actually seems better than the last one?
More nuanced versions of the reward. That sounds promising. What else?
They also want to do more qualitative analysis, like actually look at the kinds of search queries the model generates when it retries. How is it changing its approach? What is it learning about how to search better?
Yeah, peering inside the mind of the LLM as it problem solves. That would be cool.
And of course, the practical side. Analyze the trade-offs. Does allowing retries add too much latency? How much more computation does it take? Is the accuracy gain worth the potential cost?
Crucial for real-world use. Efficiency matters.
Yep. And finally, they suggest combining ReZero with other techniques. Maybe you use ReZero's retry mechanism alongside something like Deep Retrieval's better initial query generation or Rearter's improved reasoning. Could they work together?
Synergies, building on the different strengths. Makes sense.
Exactly. So wrapping up the academic significance, ReZero really introduces a novel RL strategy focused squarely on rewarding the act of retrying and RG. It's a simple concept almost, but a powerful shift away from just focusing on the first attempt or the final reasoning.
Okay, so the big takeaway, especially looking at the academic innovation here, is that ReZero's novelty is this RL approach that explicitly rewards persistence, trying again after a failed search.
That's the heart of it. This focus on incentivizing the retry is a clear departure from other RAG enhancement methods, and the initial results look pretty promising for boosting accuracy.
And for everyone listening, hopefully this deep dive gave you a more academic perspective on this specific technique. We tried to get into the how and why behind this innovation, not just a surface skim.
Yeah, we looked at the core idea, the RL mechanism with GRPO, that crucial reward retrieve function, the other rewards, the noise injection, and then the experimental results and limitations.
Right. So here's a final thought, maybe a bit more academic, to chew on. How could this idea explicitly modeling and rewarding iterative problem solving, like ReZero does with search, be applied elsewhere in AI? Think about complex reasoning, planning, maybe even creative generation. What fundamental lessons about learning, persistence, and exploration does this approach offer?
That's a great question. Definitely food for thought. And of course, if you want the full technical story, the ReZero paper itself and the broader Reich literature are out there to explore.
Thanks for joining us on this deep dive. Until next time.